Today's lesson is how to decompose and distribute like a math pro. So when we talk about decomposing, that means breaking up a number into different chunks. So 37 could be thought of as 30 plus 7. That would be one way of decomposing, and when we multiply, it's going to be a really nice way because then you've got some friendly numbers. So that's decomposing. Distributing is part of the distributive property that we have talked about before, and that's when in a multiplication problem you decompose first, and then it's kind of like you have to deal out those different parts of the decomposed number. So a math pro would look at this and say, ooh, well, 37 times 8, I could do that in my head. First, I could do 30 times 8 and figure that out. Then I could do 7 times 8, figure that out, and then just piece them together in the end. That would end up looking like this. So here is where we see the 30 times 8. Here is where we see the 7 times 8. And it's a little weird that we're adding these together if it's a multiplication problem, but here's why. Right here, and that's why they're both orange. If we decomposed in a way that shows that we have this piece and we need to put it together with this piece, putting something together is basically adding it. So we have two pieces. In the end, we put them together. So, how would a math pro finish off this problem? Well, a math pro would set it up like this with the parentheses. This is how you'll see it on tests from the state and from the district as well sometimes. A math pro would say, well, first I'm going to do this part, then I'm going to do this part, and let's see what happens when I put it together. So, go ahead and solve that and try to beat me, try to race me in this. So the first thing is the 30 times 8. Hopefully you came up with 240 because 3 times 8 is 24 and place a 0 to show multiplying by a power of 10. And the 7 times 8, hopefully you've got that already. 56 because 5, 6, 7, 8. Okay, and we still need to add these two parts together. Now, what are these two parts called? You should know, partial products. And hopefully we'll end up with a somewhat friendly number over here because we multiplied by a power of 10. So 240 plus 56, our final answer is 296. So this is a really cool way of doing a tough multiplication problem, 37 times 8. You can really do it in your head if you think about decomposing and distributing. This is how a math pro would end up writing it. You won't see too many professional mathematicians these days using a number line model. You also wouldn't see too many professional mathematicians these days using the open array, also known as the area model, unless they were doing some architecture or something where they were actually calculating like the square feet of something. But this is how a math pro would do it. And the reason is, and you're going to have to trust me on this, it gets you ready for algebra. When you're in middle school and you're doing algebra, you're going to be looking at problems that are a lot like this, but instead it's going to be exponents. Okay, don't write this next part down, but parents, if you are watching, you might remember this and you can see how this distributive property is really going to set up your kids for success in algebra. So kids, students, class, Sweet 16, only write this down if you want to. Or you can just sit there and let it blow your mind and then you don't have to worry about learning it. But here's why it works. If you're looking for an advanced challenge, here we go. In middle school algebra, you might get a problem that looks kind of like this, which would read x times 2 plus x times 6, where x represents some unknown quantity. And they might tell you, okay, simplify this equation. You need to simplify it before you can figure it out. Well, you would use the distributive property. Check it out. First, distribute one x to the other. X times x. Well, that would be x to the second power, or x squared. Then distribute the two parts on the outside. X times 6, or x groups of 6, or 6 groups of x. Now let's take our two inside parts. They're the closest to the center of this whole thing. 2 times x, or 2 groups of x. And we still need to do one more distribute. Yep, we still need to distribute 2 times 6, which would be 12. So now you have an expression x squared plus 6x plus 2x plus 12. And you can simplify that even more by combining these like terms. 6 groups of x plus 2 groups of x means that you have how many groups of x? 8 groups of x. So simplified, this would read x squared plus 8x plus 12. Trust me on this. You are going to see this a lot. And I was taught that it's like FOIL. First, outer, inner, and last. The last one's in the parentheses. We learned it like this. First, outer, inner, last spells FOIL. And if we could learn FOIL, which was basically the distributive property, we could do it. So let's see how FOIL can work with just a basic multiplication problem without all of this crazy X algebra stuff. All right, let's check it out. Okay, here's a 2-digit by 2-digit multiplication problem. Okay, the amount of energy used by different appliances can be expressed in a unit called kilowatt hours, basically the amount of energy that it uses. And let's say that a toaster uses about 39 kilowatt hours per year. Let's also say that Sage loves toast, and she's loved toast ever since she was a baby, and now she's 11 years old, and they have had this same toaster for 11 years. Must have been a good toaster. So, how many kilowatt hours has this toaster used in Sage's house for the 11 years that she has been alive? Well, what would our multiplication problem be? 39 kilowatt hours per year times 11 years. We're trying to figure out 39 times 11 to figure out how many kilowatt hours of energy Sage's toaster has used in her 11 years of life. So think about how you might break apart 39. Think about something that would be pretty friendly. We might do it different ways, but one way that I think about is by place value. 30 plus 9. And 11 could be 10 plus 1. Can't think of many more friendly numbers than 10 and 1. And we are going to use FOIL to make sure that we keep track of all of the distributing and make sure that we really multiply all of these parts by all of these parts over here. So, FOIL stood for first, outer, inner, and last. Okay, so let's do this. The first in each group here, 30 times 10. All right, and now we're going to do, well, we can check ourselves off for the first. Now we're going to do the outer ones. This is on the outside, and this is on the outside. So that's 30 plus 1. Or 30, I'm sorry, times 1. So first we did 30 times 10, then we did 30 times 1. All right, that was the outer. Now we need the inner. This is on the inside, this is on the inside, so that means 9 times 10. And at the end, I'm running out of room there, we need the last ones. So the last in the groups, 9 and 1. So 9 times 1. Wow, look at how friendly these all are. Now this is how a math pro is going to write it. They're going to write all the answers underneath. So 30 times 10, 3 times 1 is 3, place 2 zeros. Next parentheses, 30 times 1, well, that's 30. Next parentheses, 9 times 10, 90. Next parentheses, 9 times 1, 9. Now all we have to do is add them together. A way I might do this is actually group the 30 and 90 together to make 120, and then bring everything down. So we build down. So 300 plus 120 is then 420, and bring down the plus 9 would be 429. And definitely important to box up our final answer when we've got this much going on. So that's how a math pro, and we did last, that's how a math pro would show their work. They would show how they decomposed up here. They would show how they distributed and build down until they got their answer. Okay, here's another one. Oh, but before we go on, so the answer to our question about Sage's toaster is that her toaster used 429 kilowatt hours, would be the label there, in the 11 years that it has been in her house. Lots of energy by a toaster. All right, now we're ready to move on. I just happened to buy a new blender a few years ago, and I was really excited about it because it's a great blender and makes the most awesome smoothies. So I got a blender, and on average it uses about 15 kilowatt hours of energy per year. Now, I got this blender 6 years ago. So how much energy has it used in the 6 years that I've got it and the 6 years that I have been able to make delicious smoothies? Maybe I'll make them for you sometime. So here's our multiplication problem then. We've got 15 for our amount of energy times the 6 years. Now on this one, when we distribute and we decompose, it might look a little bit different depending on the problem. So check it out. I could break apart my 15 into 10 plus 5. And 6, well, it's already a one-digit number, so I might as well just leave it alone. So now I have 10 plus 5 times 6. I'm going to switch to floating dots for times because really we are kind of moving into algebra. So what I need to think of here is how to distribute the 10 to the 6 and the 5 to the 6. All right, so what I might do is I might kind of draw some lines going across to show that distributing. 10 going over to the 6. Great. That means 10 times 6. And then I need to show the 5 going over to the 6. 5 times 6. And these are both part of the whole problem that we are working with. So We'll add them together when we're done. So let's figure it out. 10 times 6 is 60. I'll add that to whatever 5 times 6 is worth, which is 30. 60 plus 30 equals 90. So my glorious blender has used 9 kilowatt hours in the 6 years that I have had it. So this is how a math pro would write the distributive property, using these parentheses and building down. 1 Earth year is approximately 365 days long, but that's not the length of a year on other planets. Other planets take a longer and some take a shorter amount of time to travel around the sun. Consider the ringed planet, Saturn. Saturn, in terms of Earth years, their length of year is actually 29 Earth years long. So 29 of our Earth years would equal 1 Saturn year. So here's a question. How many Earth years would be in 4 Saturn years? Well, let's set up a multiplication problem to figure that out. That would mean that we need to take 4 times 29 to figure that out. Okay, a few different ways of thinking about this. Let's say that Alex, Matthew, and Hayden all had different ways of using decomposition and the distributive property to figure this problem out. They all have the same problem, but all 3 ended up solving it in different ways. Take a look at how Alex, Matthew, and Hayden each set up their problem. Same problem, different ways of thinking about it. What your task is to figure out which way is going to get the right answer. It could be one of them, 2 of them, 3 of them, or none of them. Build down all 3 of these strategies like a math pro would, and you decide which way do you like the best? Which way do you think is the most efficient? Which way would you be likely to solve a problem like this? Be prepared to defend your answer to your group tomorrow.